Alright, so in today's class, we are going to discuss integration of trig functions. Integration of trigonometric functions. Do you remember the differentiation of all the trigonometric functions?
Yes, sir. I think so.
Just for a recap, what was the differentiation of sin x?
Minus cos x.
Differentiation of sin x was just cos x.
Oh,
Differentiation of cos x was minus sin x, and differentiation of tan x was
square.
secant square x. Extending this further, differentiation of sine ax plus b was differentiation of sine of ax plus b was
Ln.
differentiation of sine.
Oh,
We just did this. Sin x ki differentiation is cos x. So
yeah.
sine
Cos
ax plus b ki differentiation is going to be
cos
cos ax plus b.
and then we multiply with the differentiation of the bracket.
That's correct. So times a. Similarly, differentiation of cos ax plus b.
Um, a times minus sine x ax plus b.
So minus a sine ax plus b. And differentiation of tan ax plus b.
Uh, secant ax plus b squared times a.
All right, can you hear me now?
Yes, sir.
Okay, so we were discussing that integration is the reverse process of differentiation. So if I integrate cos x, I'll get back sin x. So integration of cos x dx is going to be sin x plus c, and integration of sin x dx is going to be, if I have to just integrate sin x and I take this minus on the other side, so the integration of sin x is going to be minus cos x plus c, and integration of secant square x dx is going to be 10x plus c. Are we clear till here?
Yes, sir.
Now, if I want to integrate cos ax plus b, then I know differentiation of sine ax plus b was a cos bx plus c. So if I just want to integrate this part, I'll have to take a on the other side. So the integration of cos ax plus b is just going to be 1 upon a sine ax plus b
So can you
plus
explain
c.
one
Or
upon
you can
a?
generate by the, yeah, sure. So if I integrate, okay, so this a is going to go on the other side, and you're going to get 1 upon a sine ax plus b. So integration of cos
Oh,
ax plus b is going to give you 1 upon a sine ax plus b. This is one way of looking at, or you can just remember that integration of cos ax plus b is sine ax plus b divided by differentiation of the angle in. So that's, this is basically, this is the reason, this is the logical reason, and this is what you can just remember.
okay.
Sine ax plus b upon the differentiation of sine ax plus b dx is going to be, sine ki differentiation is cos ax plus b, sorry, minus cos ax plus b upon a, and integration of secant square ax plus b is going to be 10 ax plus b divided by the differentiation of the angle ax plus b, which is 1 upon a plus c. Okay, so let's look at some examples now. Find 2x dx. Number 2, and integration of 4 secant square x by 2 dx. Okay, so what do you think the integration of sine 2x is going to be?
Minus cos 2x plus c.
Yes, integration of sine is minus cos 2x divided by 2 plus c. ठीक है, integration of cos 3x is going to be
Sine 3x upon 3 plus c.
sine 3x over 3 plus c. Good. And for the last, 4 secant square x upon 2.
Um, 4 tan x over 2 upon
1 half. You divide by the differentiation of the angle. Okay. So 4 upon a half is going to be 8, then x by 2 plus c. Correct?
yes.
Okay. Anything that you want to note down from this slide, or you can take a screenshot?
Okay, so hold on.
Find the exact value of integration of 3 minus 2 sine 2x dx from the limit 0 to pi by 4. Okay, so I want you to try this first. So integration of 3, it's going to be 3x, and integration of 2 sine 2x is going to be 2 minus cos 2x upon 2. Okay, and we don't need to apply, we don't need to add plus c because it's an definite integral. 3x plus cos 2x, the upper limit is pi by 4 and the lower limit is 0. So if I plug in the upper limit as pi by 4, I'm going to get 3 pi by 4 cos of 2 times pi by 4 minus 0 plus cos of 0. Cos of pi by 2 is 0, so this is going to give you 3 pi by 4 minus cos of 0 is 1, so this should be your final answer.
Yeah, so I integrated 3 wrong.
Okay. Now further integration of trigonometric functions. So we are in this case we are going to see what do we do if we have to integrate functions such as sine x or function to the power of 4x, or for example functions such as tan square x. We can't by the new power. That only works when you work in trigonometric function. What I'm trying to say is that you cannot say, okay, this is same as saying sine x cube. So I'm gonna integrate. Going to raise 1 to the power divided by the new power times the differentiation of the sine x, that is cos x. No, that is wrong because this rule of adding 1 to the power dividing by the new power works only when you have an algebraic expression encapsulated in a power. Okay, so now we are going to study some cases to help us integrate these functions. So case number 1, case 1 is when you have odd powers of sine x and cos x. So whenever you have odd powers of sin x and cos x, for example, sine of cube x, cos of cube x, sine to the power of 5x. So all these are the example when you have odd powers of sin x and cos x. So is a loaner's product, and then use the identity of sine square x plus cos. So for example, in questions where I have to integrate sine cube x, I'm going to first separate sine x alone, and I'm going to be left with sine square x. So then I can replace sine square x with the identity. So I can write sine square as x. What can I replace sine square x with if I use the identity?
1 minus cos square x.
1 minus cos square x. Right. Okay. So this is going to be sine x minus of sine x. I should have integration of expressions which
So your voice is cutting a lot. I couldn't
multiply
hear
together.
the last few things you
Just
said.
give me. Can you hear me now?
Yeah, so now I can hear you.
Let me know if you do not understand anything or you are not able to hear. Okay. I should have started creation of product first before moving on to this. So I'm going to do that first now and then come back to this, because over here you are not going to be able to solve this. Sin x times cos square x की integration आप अभी solve नहीं कर सकेंगे, ठीक है? So just give me a minute. I'm going to start integration of products first. The first form, that if you are ever exponential function that is
So now I can't hear you. It's cutting in.
some function itself, and it is being multiplied with the the power. So we have an exponential function with the differentiation of the integrate such functions, then integrate function is simply form number one. So for example, e to the power of x square with respect to, so there this x square, it's a product function x square, and the differentiation of x square is just 2x. So by observation, by this rule, the integration of this function is simply going to be e to the power of x square plus c. Okay, let's take another example. Integration of sine x times e to the power of cos x dx. So e is raised to a function. This is a product form. E is raised to the power of cos x, and a function itself, the power is the function of trig. Now, what is the differentiation of cos x?
5x.
The differentiation
Oh,
of cos x is minus sin x. So, that if I apply a negative sign, I want a negative
your voice is cutting.
so that I can say that, okay, to introduce a minus sign outside. Okay, hold on.
So your voice was cutting during that.
Fix the internet. Should I just check the? Is it still lagging? Uh, if you have a product of a function and one of the function is an exponential function that is raised to a function whose differentiation is being multiplied right beside it. So I know that the differentiation of cos x is minus sin x. So over here, a minus sign would make it a differentiation of uh, cos x. So I'm going to introduce a minus sign. So I'll have to write a minus sign outside the integral as well. Now, if I just integrate this function according to this rule, what will I get? So minus is outside the integration sign, so that is going to remain there. Now, what is the integration of this highlighted region as per the rule?
Cos x.
E to the power of, this is the integration. So e to the power of cos x plus c. That is the answer. Does this make sense?
No, sir, this doesn't.
Okay. Do you want me to go over another example or repeat the same example?
Sir, repeat the same example, please.
Sure. So I was trying, let me do this entire thing again. Is the first example clear?
Yeah.
So as a general rule, if I have a product of two functions such that one is an exponential function that is raised to some power, which itself is a function, whose differentiation is being multiplied with the exponential function. So the integration of such function is just nothing but e raised to the power of function itself. So in the first example, 2x multiplied by e to the power of x square. So it's a product form. X squared की differentiation is 2x. So this is right beside it. So integration of such function is simply going to be e to the power of x squared. The second example that we did was sine x e to the power of cos x integration. So again, it's a product form where sine x is being multiplied by e to the power of cos x, but we need to make some adjustment to apply this rule. Cos x की differentiation is minus sine x. So I'll have to write minus sine x to make it the differentiation of cos x. But if I'm changing something inside the integral sign to balance it out, I have to multiply or divide by that same quantity outside so that ये overall कुछ effect नहीं आएगा इस पे. So it's like same as saying अगर -1 से multiply कर रहा हूँ तो बाहर भी -1 से multiply कर दिया. ठीक है. Now just focus on this integral part. The minus sign outside the integral sign will remain as it is. Now this highlighted part conforms to this rule. And what was the rule? As per the rule, the integration of this function is going to be
E cos x.
e to the power of cos x plus c. That's it. So the answer is going to be minus e to the power of cos x plus c. Let's try one more example. X minus 2 times e to the power of x square minus 4x plus 5 integration dx. So x minus 2 is being multiplied by e to the power of x square minus 4x plus 5. Now I just have to check whether it conforms to the product rule that we are studying. Differentiation of the function x square minus 4x plus 5 is going to be
2x minus 4.
So right now I have x minus 2. If I just multiply this or divide by a constant value, can I get the differentiation of the power over here?
Yes.
What should I multiply x minus 2 to get the differentiation of x square minus 4x plus 5?
2.
2. So if I am multiplying this by 2 over here, should I be dividing by half? Should I be dividing by 2 as well?
Yes.
So this part, the expression inside the integral sign conforms to that rule. So the integration of such function is going to be 1 upon 2 times.
E to the power of x square minus 4x plus 5.
That's it. So that was form 1. I'm going to call it form 1. Form 1 of the product. Now let's go over form 2 of the product. Form 2 says that if I have a function who is that is raised to some power, and if I come across the differentiation of the function as a product, and if I have to integrate this type of product form, then the integration of this product form is simply going to be the function f. It is going to be raised by 1 power divided by the new power plus c. I'm going to repeat the statement. If I am being asked to integrate a function, the function that is raised to some power, and I can see the function's derivative as a product, then the integration of such expression is simply going to be the function inside the bracket, raise the power of the function by 1, so n plus 1, divided by the new power n plus 1 plus c. For example, cos x times sine cube x integration. So it's a product form. If I treat sine x as my function and it is raised to some power 3, it is raised to the function is raised to the power of 3, and the differentiation of the function is being multiplied with it is being written as a product form. So integration of such function is going to be the function itself, raise the power of the function by 1, so 3 plus 1, divided by the new power 3 plus 1. So that is going to be sine x to the power of 4 over 4 plus c. Is it making sense? Yes?
Yes.
Let's take another example. X squared times x cubed minus 1 to the power of 4 dx. So we have a product form where x cubed minus 1 to the power 4 is being multiplied by x squared. So one thing is confirmed, it's a product form. Now I'm going to check, is this function that is encapsulated in bracket, I'm going to call this as my f, the function. It is being raised to the power of 4. Is it possible to make this the term being multiplied as a derivative of x cubed minus 1? What is the derivative of x cubed minus 1?
2x square.
3x square. X cubed, okay, differentiation is going to be 3x square. So I must have 3 over here so that it conforms to being the derivative of x cubed minus 1. So if I want 3 over here outside the integral sign, I'm going to multiply it by 1 upon 3. Now, if I just focus on this part, the integral part, The integration of such function is going to be 1 upon 3 will remain same. Integration of this function is going to be
X to the power of 3 minus 1 to the power of 5 upon 5.
very good. X cube minus 1 to the power of 5 upon 5 plus c, which is going to be 1 upon 15 x cube minus 1 to the power of 5 plus c. Okay. Do you get this idea?
Yes, sir.
Okay. Now, if I move on to the trig integration, now you will be able to integrate this function. So integration of sine x is very simple. What was the integration of sine x?
Minus cos x.
Minus cos x minus, okay. Now integration of sine x multiplied by cos square x. So what I can do is I can write cos square x as cos x the whole thing square. Is this a product form?
Yeah.
Yes. So cos x is my function which is raised to the power of 2, and it is being multiplied by the differentiation of the function. So what is the differentiation of cos x?
Sin x.
It's minus sin x, differentiation. So
Yeah.
I'll have to make some adjustment over here. If I add negative sign over here to confirm to the derivative of cos x, do you think I should have multiply the negative sign outside as well?
Yes.
So minus the minus sign outside and minus is going to be plus. And what is going to be the integration of this product?
Minus cos x to the power of 3 over 3 plus c.
Right. But I have already used this minus sign with this minus sign to make it plus. So it's just going to be cos x function raised to the power by 1. So 3 upon 3. And then you're going to write a combined c plus c. So this was a question in which we were asked to integrate sin x or cos x key odd powers. Odd powers means sin cube x, sin to the power of 5x, sin to the power of 7x. But we generally we won't get too many such a high power. So let's say if you get a question in which you are being asked to integrate sine to cube x, so the first step is going to be that you separate sine x or cos x as a product. So in a question where you have sine cube x, the first step is going to be that you separate sine x as a product. So sine x multiplied by sine square x. Okay, sine x times sine square x. So integration of sine x times sine square x, then you're going to use the identity sine square x plus cos square x is identical to 1. So if you replace sine square x with the 1 minus, you're going to replace it with 1 minus cos square x. Then when you multiply, you are going to get sine x minus sine x cos square x. Then integration of sine x was simple, minus cos x. And then we use the product rule form 2, and you get cos x cube, cos x to the power of 3 plus upon 3. Did you understand this?
Yeah.
Okay. Now, do you want to try a question on cos cube x?
Okay.
Integration of cos cube x. What is going to be the first step? It's an odd power of trig cos x.
Yeah.
So integration of cos cube x is going to be,
Cos x times cos square x.
yes, integration of this. You separate a loner pair, then you are going to use the identity to replace this. So cos x times 1 minus sine square x dx. You multiply cos x by 1, so you get cos x. You multiply cos x with sine x square, so you get sine. So now I know that I'm going to use the product rule, so I'm going to write sine x as sine x the whole thing square. I need to integrate this. So what is integration of cos x?
Minus sine x.
It's plus sine x. Integration of cos x is plus sine x. And coming over here where we have a product, so cos x multiplied by sin x plus square, the function is sin x. What is the differentiation of sin x?
Minus cos x.
Okay, let me get you back over here. The differentiation of sin x is cos x and the differentiation of cos x is minus sin x. जब इंटीग्रेट करते हैं तो cos x की इंटीग्रेशन इज प्लस sin x and sin x की इंटीग्रेशन इज minus cos x. Okay,
Okay.
so now if I ask you what is the differentiation of sin x,
Minus cos x.
the
Oh,
differentiation of sin,
differentiation is cos x.
yeah, the differentiation is going to be positive cos x. So I don't need to make any changes. I directly have the differentiation of sin x right beside it being multiplied. So this conforms to the product form too, the minus sign as it is. Now I'm going to integrate this and I'm going to get sin x cube upon 3 plus c. Okay, that was case 1. Okay, let me know if you have any questions so far.
No, so I'm fine.
Okay, should I move on?
Yes.
Okay, then we are going to discuss case 2. These are the cases for integrating trigonometric functions. So case 1 was dealing with the odd powers of sin x and cos x. Now we are going to do case 2 for even powers of sin x and cos x. So whenever we have even powers of sin x and cos x, for example, sin square x की integration, ठीक है, and let's say, yeah, first of all, let's do sin square x integration. So to integrate these kinds of functions, we are going to follow some rules. Whenever we have even powers of sin x and cos x, we are going to use the identities of cos 2x. Do you remember cos 2x? This is the double angle, and there were some double angle identities. Cos 2x can be written as 2 cos square x minus 1, or cos 2x can be written as 1 minus 2 sine square x. Can you recall these two identities when we were doing trigonometry? Double angle identities जब हमने देखी थी.
Yeah.
Do you want me to go back to trick slide and show you?
No, so I remember.
Okay. So we are going to use these trig identities, double angle identity of cos 2x particularly, to integrate sine square x. As I said, we just can't integrate sine square x by saying sine cube x upon 3. No, it doesn't work like that. So if I have to integrate sine square x, I'm going to make use of this double angle identity, and sine square x comes, so I'm going to use this cos 2x equal to 1 minus 2 sine square x. and I'm going to make sine square x the subject. So 2 sine square x is going to be 1 minus cos 2x, and sine square x is going to be 1 minus cos 2x upon 2. Okay, 1 minus cos 2x upon 2. So I'm going to replace sine square with 1 minus cos 2x upon 2. 1 minus cos 2x upon 2. So far, so clear?
Yes.
Now what you can do is you can take half 1 upon 2 common outside the integral sign, and you're going to be left with integral of 1 minus cos 2x dx. Now this is simple to integrate. Integration of 1 is
Nothing. Zero.
integration
Oh,
of 1 x minus integration of cos 2x would be. Now remember, recall करो पहले कि cos की integration क्या होती है? Is it minus sign or plus sign?
plus sign.
Plus sign. So integration of cos 2x is plus sign. So integration of cos 2x is going to be sine 2x over 2. Okay. Then you can write a combined c over here, and you can simplify this further out. So x upon 2 minus sine 2x upon 4 plus c.
Also, why is it upon 4?
Because 1 upon 2 multiplied by sine 2x upon 2 is going to give you sine 2x upon 4.
Yeah.
What is going to be the integration of 3 cos square 2x dx? So try this out. So you can just confirm your answer with mine. First of all, I can take 3 common. Integration of cos square 2x dx. It's an even power. So for even power, I can just use the double angle identity. So, but over here, I know that cos 2x is equal to 1 minus uh, 2 cos square x minus 1. 2 cos square x minus 1. Okay, that is the double angle identity. But right now, in this question, I have to integrate cos 2x the whole thing squared. The squared term has 2x over here. Okay, so that means over here I will be needing cos 2x. The ratio of this angle is to this angle is 2 is to 1. That is why we call it double angle identity. So according to you, if I have 2x over here, what should be the angle present on the left hand side? Cos of hi. Can you hear me?
Yes, I can hear you.
Did you hear the question?
Yes, I'm not
Okay.
sure. Is it? Yes,
So
I'm not.
basically, it's called double angle identity for a reason, and that reason is that if I have the angle 1x over here, I'm going to have twice the angle over here, 2x. So the
No,
idea is that if I have 2x, so here I should have 4x.
Or
Now I'm going to make cos 2x squared the subject. So if I do that, I'm going to get cos 4x plus 1 over 2. That is going to be equal to cos squared 2x. This is what I need to integrate. So I'm going to replace this with this expression cos 4x plus 1 over 2. And I can take 2 outside. So integration of simple cos 4x plus 1. Integration of cos 4x is going to be sine 4x upon 4 plus integration of 1 is going to be x plus c. So as a final step, I'm going to get 3 upon 8 sine 4x plus 3 upon 2 x plus c. Please note down this working, and if you have any question, please ask. So in this question, what you are going to do, the first step is going to be that you're going to write sine to the power of 4x as sine square x cos square, right?
yes.
And if we just recall, now since it's an even power of sine x, so obviously we have to use this identity. We know that cos 2x was 1 minus 2 sine square x, but so you can replace sine square x with, if I make sine square x the subject, I'm going to get 1 minus cos 2x upon 2. Is that correct?
Yes.
So sine square x is going to be replaced with 1 minus cos 2x upon 2, the whole thing square. Now I can expand this using the expansion identity of a minus b the whole thing square. The first term is going to be 1 minus, I'm using a minus b the whole thing square identity, that was a square minus 2 plus b square. So 2 cos 2x plus cos 2x squared upon 4. I can take 1 over 4 outside, and I just need to integrate this expression. But to integrate this guy, again, it's a double angle identity. So cos 2x squared, okay, we have a square over here again. So if I just recall, cos 2x was can also be written as 2 cos square x minus 1. But I want cos 2x square, so which means I want twice the angle over here. So this angle is going to be twice. If I want 2 cos 2x over here, then this angle should be cos 4x. So cos 2x the whole thing squared is going to be cos 4x plus 1 upon 2. Like we just did in the previous question over here. Okay?
Okay.
So before integrating, I'm going to replace this with cos 4x plus 1 upon 2. Now I can integrate that. So integration of 1 is going to be,
X.
yeah, x. Integration of 2 cos 2x is going to be,
2 sine 2y.
2 sine 2x upon 2. Now, if you want, you can split this up. I should have simplified this further. You can split this up as cos 4x upon 2 plus 1 upon 2. Integration of cos 4x upon 2 is going to be
Sine 4x upon 2.
so 1 upon 2 as it is sine 4x upon 4, right?
Yeah.
And integration of 1 upon 2 is going to be 1 upon 2x plus c. Now, simplify how much is possible. So x plus half x is 3 upon 2x minus sine 2x plus sine 4x upon 8 plus c. Just multiply this with 1 over 4, so you're going to get 3 upon 8x minus sine 2x upon 4 plus sine 4x upon 32 plus c. This is going to be our final answer. Over this week, I really want you to go over all the integration that we have done so far. We have, okay, so this is going to get you more practice. यही वाले क्वेश्चन वापस से सॉल्व कर लेना.
Okay.
Okay. Do you have the energy to do one more case?
Yeah, so sure.
Okay. Now the third case is for the power of 10x. We were done with even power of sin x and even power of cos x and sin x. Now the case 3 is power of 10x. So over here it will not matter whether the power is even or odd. It's just power of 10x. So the rules are such that you need to make use of this identity. 10 squared x is identical to secant squared x minus 1. Okay. But in case of powers higher than 10 square x, let's say 10 cube x, then what you do is you separate 10 square x as a product and then use this identity of 10 square x equals to secant square x minus 1. So let's do an example. Let's integrate 10 square x. So integration of 10 square x, it's an power of 10x. So right away, I'm going to use the identity secant square x minus 1. What is the integration of secant square x?
Um, tan x.
Yes, 10x. And integration of 1 is going to be x. That's it. Let's see how to integrate 10 cube x. So in order to integrate 10 cube x, you are going to separate 10 square x times 10x, and you're going to use the identity secant square x minus 1 times 10x. So this gives you secant square x times 10x minus 10x dx. So far with me?
Yes, sir.
Okay, now I want you to think for some time and tell me, how do you plan on trying to integrate this function? There is a function whose differentiation is being multiplied as a product. is being multiplied with it. What is that function?
Tan X?
Right. Very good. So the function is 10x. It is raised to the power of 1. And its differentiation is being multiplied right beside it. So which form is this? Does this conform to form 2 of the product rule?
Yes.
So what is going to be the integration of secant square x times 10x?
Tan. One second. Tan X upon
10x, you raise the power of the function by 1, so it is going to be 2
upon 2.
upon 2. Very good. Now, I haven't taught you 10x. Do you remember 10x integration?
Is it minus secant square?
No. 10x की differentiation was secant square x, and secant square x की integration was 10x. I haven't taught you 10x की integration. Like we haven't discussed this.
Yeah.
So use your observation. 10x is basically a ratio of sine x over cos x. Whenever you have, acha, what is the differentiation of cos x?
Sine X.
Differentiation of cos x is minus sine x.
Oh yeah.
So if I want the numerator to become the differentiation of the denominator, I'll have to apply a minus sign over here. So I'm going to apply a minus sign outside as well. Now, do you remember in the last class, which was yesterday, we did differentiation of fractions in which the numerator was the differentiation of the denominator.
Yeah.
So what form was that? After integration, what do you get?
Um, the differentiation of the numerator, or just the numerator?
So the integration, let me just take you to that slide. Okay. So if the differentiation of the denominator was present in the numerator, we said that the integration of such function is going to be ln of the denominator. For example, consider this example again. You were given 1 upon minus 2x plus 3. Now, differentiation of minus 2x plus 3 is minus 2. So you multiplied it by minus 2 to confirm the numerator to have the differentiation of the denominator. If you multiply the numerator by minus 2, obviously this is something you were doing on your own, so you divide it as well. But when you see this expression inside the integral sign, if this conforms to the rule, then the integration of this was ln of the denominator, that is ln of minus 2x plus 3. So coming back over here, if I know that minus sine x is the differentiation of cos x and minus sine x is present in the numerator, so integration of such function is going to be, integration of this function is going to be ln of the denominator.
Okay.
Okay. And what will happen to this minus sign? This is going to be over here. So I can write this as minus integration of 10x is minus ln cos x. Now we don't expect you to remember this identity, but you should try to get it using this identity sin x over cos x. Minus minus is going to be plus, so overall answer is going to be 10 square x over 2 plus ln of cos x.
Okay.
Okay. I think you are finding it a little difficult. Is that
Yes,
correct?
I am.
So, what over the weekend, if you're done with your exams, please do revise this before coming to the next class. Okay.
Okay.
Find the exact value of integration of 5 tan square x dx from 0 to pi by 4. Come on, you can do this with me. Tell me the first step.
You make it tan.
The first step is that you identify that it's a power of 10x. So if it's 10 square x, you just have to use the identity. What was the identity? Secant square x minus 1. So I'm going to replace 10 square x with secant square x minus 1. Everything stays the same. That's my first step. Okay.
Okay.
Then what?
You integrate secant square x minus
Yeah,
1.
first of all, you are going to multiply 5 with secant square x, then 5. Yeah. Now, what is going to be the integration of 5 secant square x?
Uh, 5 tan x upon 5.
5 tan x, not upon 5, because 5 is just a coefficient. अगर वो एंगल में होता ना 5, तो फिर डिवाइड होता, ठीक है? So that is 5 tan x.
Minus
Now
5.
integration of 5x हो जाएगा ये. Limits are going to be pi upon 4, 0. Make sure your calculator is in radian mode. You just have to substitute the limits.
Okay. Yeah, so I got it in decimal form because my calculator doesn't give it like that.
Yeah, the question, please be aware of such questions where the question says exact value. Sometimes if you plug in the entire expression in the calculator, you won't be getting the exact value. So you must remember few trig ratios, for example, tan of pi by 4. Now, if you remember that pi by 4 is equivalent to 45 degrees, tan of 45 is 1. So that's why the answer for tan pi by 4 is going to come out as 1. So this makes it 5 minus 5 pi over 4. Okay?
Yeah.
Show that if y is equal to secant x, then dy by dx is going to be equal to 10x secant x. This is part A. Part B says, hence, find the exact value of the integration of cos 2x plus 5 10x secant x dx from the limits 0 pi by 4. So first thing first, we need to show that if y is equal to secant x, then dy by dx is coming out to be 10x secant x. So for the first part, I'm going to make use of this equation y equal to secant x. Now, I do not know the differentiation of secant x, but if I know what is secant x equal to, I can do something out of it. Secant x is 1 over cos x. Now this is a fraction in which you have the numerator and the denominator. You can call the numerator as u and the denominator as v. So the derivative is going to be simply equal to the quotient rule. U is 1 and v is cos x. U prime is going to be 0 and v prime is going to be v prime is going to be
Oh, minus sine x.
minus sine x. Good. So vu prime minus v prime over v square, that is cos square x. So this gives us sine x upon cos square x. But they want us to show that dy by dx is equal to 10x secant x. So I need to just prove this as an identity. You're going to break down cos square x as cos x into cos x. And if you just remember, sine x upon cos x is 10x and 1 upon cos x is secant square x. So
Yeah.
this gives you 10x times secant x. ठीक है?
Okay.
Okay. Now, for the second part, they want you to find the exact value of this integration, and this is one of the command word that CI use. Hence means that it has something to do, the solution or the working of this part has something to do with the answer to the first part. So, if I am asked to integrate cos 2x plus 5 10x secant x from 0 to pi by 4, what I can just do is I can split the terms and write integration of cos 2x first plus integration of 5 10x secant x dx. I know the limits are same. So what is the integration of cos 2x?
Uh, Sine 2x over 2.
Perfect. Now what is the integration of, now this 5 is a constant number, I can take it outside the integral sign. You just tell me what is going to be the integration of 10x secant x.
Um, Secant square x and tan x.
No, no. Secant x. So you are trying to apply the product rule over here, but this does not conform to the product rule because 10x की differentiation secant square x होती है. So that is not possible. वो form 2 is not complying over here. If you just see the first part statement, if I have a function y is equal to secant x और उसकी differentiation comes out to be 10x secant x. So I know integration is the reverse process. So if I am going to integrate 10x secant x, don't you think I'm going to get secant x back?
Yes.
So integration of 5 10x secant x is simply going to be 5, and integration of 10x secant x is going to be secant x. That's it. So
Okay.
there are going to be some question in which the question is going to test your knowledge about the idea of integration, which is that it is the reverse of differentiation. So 5 secant x, and we already have the limits with us, that is pi by 4 and 0. So we are going to substitute the limits now. Sine of 2 times pi by 4 upon 2 plus 5 times secant pi by 4. When I will plug in 0, I know I'm going to get 0 for the first. And जब 0 plug in करूँगा यहाँ पे secant x में, secant x is 1 over cos x. तो 1 over cos of 0 is 1. So 1 upon 1 is 1, or 1 times 5 is 5. So minus 5. Is that correct?
Yes, sir.
Sine of 2 pi upon 4 is same as saying sine of pi by 2. And sine of pi by 2 is same as sine of 90, which is 1. So 1 upon 2. Secant pi by 4 is same as saying 1 upon cos pi by 4. 1 upon cos pi by 4 was, now here you can use the calculator if you want. 1 upon cos pi by 4 is going to come out as
Root 2.
root 2. Root 2. So this comes out to be 5 upon root 2. just a second. Cos pi by 4 is root 2 upon 2, which is 1 over root 2, same thing. Yeah, so 5 upon root 2 plus 5. Are we making mistake? Oh, sorry, this was plus 5. So this is going to be negative 5. Yeah. So we can simplify this further. So if I use my calculator to solve this further, I'm going to get 5 root 2 upon 2, and 1 upon 2 minus 5 is going to be minus 9 upon 2, minus 4.5 over this. So this is the answer. Is that okay?
Yes, sir, that's fine.
Okay. So I have 2 questions left. I can take that to the next class now. Okay. So I want you to revise till here, till the next
Yes.
class. All right. Take care.
Thank you.
You're welcome.
Okay.